Hello, students. We're doing topic 3, which is transformations, and we're talking about 3 transformations. We're talking about reflections, translations, the one for today, and tomorrow we'll do rotations. These are the types of transformations that maintain congruence. It means you do this thing to a shape and the shape stays the same size and same shape as what you started with. So what is a translation? Not a Google translation. Yes, this means hello. Yes, this means hello. But the types of translation, the word translation in geometry has a very specific meaning. Here's what it is in geometry class. So we have our original figure. In this case, it's a triangle ABC. And we are grabbing it and we're sliding it down the coordinate plane. We're taking this point A and we are moving it forward that way and 6 that way. Okay, so we're translating it. It was over here and now it's over here. How did it get there? It moved 4 to the left and 6 down. If you do that same thing to B, 1, 2, 3, 4, 5, 6, you end up at B prime. So a translation is simply you take the shape and you move it to the left and down, or to the right and up, or down and to the right, or up and to the left, lots of different ways. And what is this saying? It's saying that this length is the same. So these line segments that connect the original to the image are going to be the same. Everything moved the same amount. It's a rigid motion, so that if this angle and this angle are the same, angle B is still the same size as angle B prime, and all the shapes are, all the line segments are the same length. They're all congruent. Okay, so what is this asking us to do? It says, what is the graph of T? What do you think T stands for? Translation. And then it has like a, it's pointy. It's not a parentheses. It has a point right there. Wow, Rosie's super excited about something. We have a point. So this is the way your textbook is doing translations. And this is kind of vector notation. This means you're going to move it 7 and you're going to move it -4. I created a GeoGebra with triangle EFG. I want you guys to play around with GeoGebra. One thing to play with is you can turn on the axis and the grid. Okay, so if you start, it'll be like that. If you want to see the axis, it's a good idea to turn it on. Okay, and what am I going to do to this? Well, I'm going to make the technology do it for me. I'm supposed to translate it 7, -4. So I'm going to go, and it should say more right here. So if you first open it up for the first time, it will say more. And you want to scroll down until you see the tools that we're playing with now, which is the transformation tools. And we're going to translate this by vector. We're going to move it 7 and we're going to move it -4. Okay. Translate by vector. Select the object, which is this triangle, triangle E, and then we're going to move it 7 and 4. So actually, I don't have a vector yet. Will it let me do it? Yes. Okay, this is a vector. Undo that. I'm going to undo that. Okay. I'm going to translate it by vector. I'm going to, oops. And these, you just got to play around with this a little bit. Translate by vector. Select the object, which is the triangle. Oh my. Well, let me get the, oh boy. Okay, select the object, which is the triangle. That's only going to give me the line segment. I want the whole triangle. My goodness. Okay, select the object, the triangle. There it is. See how it turned selected? And now we want the vector. And the vector was 7, -4. I'm going to start it here and I'm going to go 7, 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 4, 1, 2, 3, 4. Something really cool is going to happen when I click this. It's going to move the triangle. And how did it move the triangle? It moved it. That's like any tool, you got to play around with it. It moved it 7 to the right and 4 down. Every point moves 7 to the right and 4 down. Every point moves 7 to the right and 4 down. Okay, let's go back to here. So if I was going to do this by hand, I would take each point and move it 7, 2, 3, 4, 5, 6, 7, and 4 down. 1, 2, 3, 4. So the new E prime is at 2, 0. Like we did yesterday, we can make a list. So regular E was at -5, 4. And the new E is at 2, 0. Okay. The original F was at -1, 5. The new F is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That's what 7, -4 means, if it has the little pointy sides on it. It's at 6, 1. Now, could you do this without a graph? And the original G was here, and we're going to translate it 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4. You can see that the triangle we started with is the same size and shape. It's congruent to the triangle we ended with. The original point was -2, -1, and the image was 5, -. Now, what would you do with this number to get to this number? What would you do with this number to get to this sum number? Okay, here's another one. What are the vertices E, F, G after a different translation, a translation of 6, -7? Well, one way to do this is to take your points. That's a point, sorry. And to the first number, the x coordinate, you are going to add 6. And to the y coordinate, you are going to subtract 7. So let's see if we can apply that. We already knew that point E was at -5, 4. And if I want to find out where the translation is, I'm going to add 6. -5 plus 6 is 1. And I'm going to take away 7. 4 minus 7 is -3. And if you're not sure, you can count it. We would go 6, 1, 2, 3, 4, 5, 6, and down 7. 1, 2, 3, 4, 6, 7. Hey, that's what I got. 1, -3. Yeah, then you do it again. F was at -1, 5. So the new F, what am I going to do? I'm going to add 6 to the x coordinate. -1 plus 6 is 5. And I'm going to do 5 minus 7, which is -2. And then G is -2, -1. And I'm going to add 6 with -2, and I get 4. And I'm going to do -1 minus 7. I'm going to get -8. So this is the change, the left, right, and this is the up, down. So adding 6, taking away 7. And this, I just already showed you this. Okay, so let's say I don't want to do this one. Let's say I don't want to think about it. So I could just add 11 and 2 to the x and y coordinates. I'm gonna be stubborn and go to GeoGebra and do it again. So now I don't want to move it 7, 4. Now I want to move it 11 and 2. Okay. And I don't know if I can. Just kind of playing around with it. See if it can tell me the answer. So this program's a little different. The calculus teacher really likes this program. Okay, let's go back and just see what it is. So this is the same problem over and over again. E was at -5, 4, and now it's at, we're adding 11, so that's going to be 6. And we're adding 2, so that's also going to be 6. The original was at -1, 5. If I add 11 to -1, I get 10. If I add 2 to 5, I get 7. And last one was at -2, -1. And the new one, after a translation, is going to be 8. Oops, not 8. -2 plus 11. 9. 9, 1. This is making sense. Okay, we can also do this another way. We can say, here's the answer, essentially. What was the translation? Okay. So if I want to say, what did I translate? How much and how much? To quadrilateral STUV to get to S prime, T prime, U prime, B prime. What was the move that happened? Well, I can just, all I have to do is choose one of the vertices. So I'm going to choose point S. And I'm going to say, okay, it went 1 back, and it went 1, 2, 3, 4 down. So it went left 1 and 4 down. That's it. And what's the relationship between the original and the image? They are congruent. They're the same size and shape, they're just in a different place on the coordinate plane. All right, one other thing that happens in this section is we can look at a composition of rigid motions. So you can translate things, and after that you can reflect them. One thing that's interesting about this notation is it works backwards. This is your object, triangle ABC, and this is the first thing that happens to it. It's kind of weird. We read it almost from right to left instead of left to right. So here's the shape we're starting with. Then we move it, we slide it, we translate it, 2 to the left and 5 up. And then we reflect it over some line called L. T stands for translate, capital R is for reflect. One thing that's interesting is if you have 2 translations, you can smash them together and just rewrite it as one simple translation. So let's say I'm doing all of this to point P. And point P, we'll just call it like that. Okay, and I'm going to tell you that point P is the point 1, 5. Okay, let's see what this is like. This was a question on the final last year. Okay, so the point 1, 5, 1, 2, 3, 4, 5 is right here. That's point P. And the first thing I'm going to do is the one next to it on the left. So this is the first thing. We start here. It's very backwards. So I'm going to add 1 and take away 1. So I'm going to move it 1 to the right and down 1. So my new one, P prime, is going to be right here. You can see it. If I added 1, I would get to 2. And if I subtracted 1, I would get to 4. Is this the point 2, 4? 1, 2, 1, 2, 3, 4. Yep. Okay, now I'm going to take P prime and I'm going to do the next translation. So I'm going to take the image and I'm going to move it to the right 3 and down 2. This is going to be P double prime because I did it two different transformations, 2 translations. So P double prime, I would take this one and I would add 3. So that's going to be 5. And I have 4 and I'm going to take away. So 1, 2, 3, 4, 5, 1, 2. Yay, I did it. Okay, is there a shortcut way to do that? Can I just take P and do something to let it land here without doing this middle step? That's all this is asking. So what one translation would take you from P to P double prime? And just all you have to do is add these together. So this would be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 3. Yeah, this is the answer to this problem. Okay, check this out, you guys. What's 3 plus 1? 4. What's -2 plus -1? -3. So if you have multiple translations and you want a shortcut to go from the first one to the end image, all you have to do is add the horizontal moves, the first numbers together, and the vertical moves, add those together. This is interesting. We're not going to get into this too much, but a translation, you could get away with not doing a translation. So if for some reason translations were broken and you couldn't use them anymore, ever, you could never slide something around a coordinate plane, you can use reflections to get to the same place. So I don't know why you would do this, but it's an interesting idea, which is if I want to take triangle ABC and I want it to land over here, which would be really easy just to slide it straight over, right? But let's say I'm for some reason not allowed to use translations, I could reflect it and then I could reflect it again and that would get it to move over. That's all this is saying. Okay, that's it. Hope that makes sense. Practice. Be good. Do your homework.